Hi guys, we are finally done with geometry and we're moving into the next chapter today, which deals with statistics. And basically, statistics is a whole nother branch of mathematics that we use. And what is statistics? It's basically a branch that deals with collecting, organizing, analyzing, and looking over information and reporting on it. And so this is what we're doing today is we're getting right into finding out the different ways of finding the possible combination of things. And we're going to deal with tree diagrams. It's been a long day. Okay, so in life, there's a lot of different combinations that we can put together and arrange different things. And sometimes we want to know how many possible combinations there can be. So we want to try to make it as easy as possible. And the tree diagram is one of those ways. And basically, it's a diagram with structure that has branches that coming off that connect the lines and represent different information. Okay, so here we're going to look at an example that we have. Okay, and our example here deals with making arrangements of some letters. We're only going to use 3 letters, A, B, and C, and we cannot repeat any of those letters. Okay, so the very first thing that I'm going to do is to make a vertical list. So here I'm making a vertical list of my 3 combinations that I have of my letters, my A, B, and C. The second step, it says that I'm going to use a branch that goes from my first vertical list to list the other possibilities. So here, the next step is I have 2 branches because I've got 2 other letters that I can use. And I can't repeat A, so I knew my other options were B, C. Here for B, my other option was A and C. Here for C, the only other options I have are A and B. Now, from that, I need to do one more branch because I have the 3rd letter I need to worry about. And since I can't repeat the letters, I knew my only option here was C. I have AC, so the only option was B. Here, BA, I knew it had to be C. BC, it had to be A. CA, B, CBA. Okay, so now I've used up all my 3 letters. I haven't repeated any combinations. And so now to find out how many total combinations there are, I'm going to go to that last branch and count up every possible thing there is. So there's 1, 2, 3, 4, 5, 6. So I know there are 6 different arrangements of putting A, B, C together without repeating any of those letters. Okay, let's take this example and apply it to something else. Nothing with letters or anything. Let's talk about John here. John, you're going on a weekend camping trip and you're very conscious about what clothes you're going to bring. Okay, and so you decide that you're bringing clothes you can mix and match, and you want to know how many combination of outfits you can do. So we're going to start off with our tree diagram. And the very first thing we're going to worry about is you need pants. Okay, so you're going to bring a pair of khaki pants. You're going to bring a pair of blue jeans. And you're going to bring 1 pair of shorts. Okay, so here's my vertical list of my option of pants. Now from those pants, I'm going to worry about my shirts. Okay, and it says he doesn't want to repeat any of these. So I'm going to go off and do 3 branches here. And it's 3 because I have 3 different color shirts. I've got my white shirt, I've got my red shirt, and I've got my green shirt. And I'm going to do this combination for every pair of pants here. Red and green, red and green. And here I have, white, red, and green. Okay, now I've taken care of my shirts. Now I have socks. And from every combination here, I have 2 options of socks. I can wear my white socks, I can wear my black socks. I can wear the white socks and black, the white and the black pair. So with every combination, I've got my white and I've got the black. I got the white socks, the black socks, the white socks, the black socks. Okay, go down through your list. If you noticed, I left a big space in between. You're going to want to give yourself room. Okay? So now to find my total combinations. If you notice, yeah, I might be wearing my khakis and my white shirt, But hey, I've got the option. One day I can wear them with white socks, and the next day I can wear it with the black socks. I've got two complete different outfits. So how many options do I have? I'm going to go through and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 possible combinations. Okay, what if we got bigger? Do you really want to be making all of these combinations and tables and your tree diagrams? No, it takes a long time to do this stuff. So there is another thing called our fundamental principle of counting. Okay, the fundamental principle of counting takes an effect of what we're working with here. So we're going to use this example here. Okay, let me flip it over. Give some room here. And so here I've got an arrangement of 3-letter words that we're going to talk about using only the letters W, X, Y, and Z without any repetition. Okay, now I could make my tree diagram, but it would get pretty lengthy. So what I'm going to do is I've got an arrangement of 3-letter words using only those letters. Okay, and I can't repeat them. So if I'm making 3-letter words, I'm going to have 3 basic spots, right? And so the very first time that I go to pick a letter, and it says I can't repeat them, right? So the very first time I go in to grab a letter to do, I've got 4 different options of letters that I can choose from. Okay, now I can't repeat it, so I'm going to take that letter that I just had and put it off to the side, and then I'm going to put my hand in the bag again, basically, and grab another letter from. How many letters do I have this time to grab from? I only have 3. Okay, so I grab that letter, I put it off to the side. Now I have that bag to grab another letter from, and how many are in that bag right now? There's only 2 left. So what I'm going to do with the fundamental counting theorem, basically, it says I go ahead and now I multiply these together. So 4 times 3 is 12. 12 times 2 is 24. There are 24 combinations that I could make with this rule. Okay? That's a lot easier than sitting here and making that big diagram. Okay? Here's another example. The ways of choosing pairs of shoes and socks. If the shoes are black or brown and the socks are navy, tan, and white, how many options do I have? And so I can basically go ahead. I've got 2 options of shoes, and I have 3 options of socks. So this one's short and sweet. All I'm going to do is go ahead and multiply 2 times 3, and I get 6. Okay, this is how our combinations work here with using the tree diagram or using the fundamental principle of counting. Okay, go ahead, look through your book and follow through. If you got any questions, text or email me, guys. Have a great day. Bye.